Alright guys, for the 5.2 notes, we're going to start out factoring just like we did in Chapter 4 and solving just like we did in Chapter 4. But then we're going to make some sketches based on what we learned in 5.1 and this factoring and solving. So, for problem 1, they want to know what is the factored form of x cubed minus 2x squared minus 15x. So, this one has an x cubed. When we were in Chapter 4 working with quadratics, the biggest exponent we had was x to the second. So we factored those. What is the very first rule of factoring always? GCF. Do I have a GCF this time? Yeah, it is an x. So let's factor that out. And that's going to leave me in parentheses with x squared minus 2x minus 15. Then I can take this trinomial and factor it again. It will factor into my two parentheses. Put an x in each one so that I get x squared. Then do I need two positives, two negatives, or one of each? And now, what numbers do I need so that they multiply to be negative 15 and add to be negative 2? How about a positive 3 and a negative 5? Yeah, I don't think the 2 will work. 3 works. So that's the factored form. Now, if they asked you to solve this, you have to set each factor equal to 0. Well, this x is a factor just like both of these parentheses are. So I'm going to set up x equals 0, x plus 3 equals 0, and x minus 5 equals 0. So this is one of my solutions, and then I just solve the other two. So x also equals negative 3, and x equals 5. Okay, and remember, this started out as an x to the third. It's a third degree polynomial. I should have 3 answers, or 3 solutions. What we're going to do from here is figure out how to draw a rough sketch of this graph, and you don't need a graphing calculator to do it. So here's where we start. My solutions, I'm just going to list them here: 0, negative 3, and 5. Go back to your original equation here, or original polynomial, and what's the end behavior of that going to be? Down, up, because my leading coefficient is positive and it's an odd degree. So it is down, up. So now, let me get my graph paper here. And I'm going to go ahead and put that information on my graph. Okay, so start out putting your solutions. 0, negative 3, and 5. Now I'm going to put my end behavior on. Okay, I know on the left side it has to point down. So go to that x-intercept as far on the left as you can, and from there it's got to go down. The right side has to go up, so go to that x-intercept on the right side, and my graph goes up from there. That much I know for sure. Okay, so let me put my steps over here. First, I plot the solutions on the x-axis. And I draw in the end behavior. And now what I'm going to do is I'm just simply going to sketch, and that's all it is. It's a rough sketch of the middle of the graph. Okay, let's talk about how to do that. And I'm going to change colors here just so y'all can see the part that's accurate is in red. The sketch part is going to be in yellow highlighter. Okay. If I start over here on the left-hand side of the graph and I start tracing it, I know it's got to go this direction, go through that -3, and then doesn't it have to go up and turn around somewhere so that it can come back to this point right here? Okay. This is the part I don't know how high up it is supposed to go. That's why this is a rough sketch. It might go higher than that, it might not go that high. But from here, I've now got to go under the x-axis, turn around somewhere so that I can come back to this point. Okay, so if you're looking at my graph, the red is fairly accurate. And the highlight is just a sketch. It is approximate. Okay, let's scoot that on up for you a little bit. Anybody still copying? Nope. Alright. So now, for the next one, there's problem 2, and it is already in factored form. I need you to go ahead and solve this. And then you can put your solutions on the graph. And then we've got to talk about end behavior here just a little bit. Alright, so once you're done solving and you have plotted those solutions, double check yours with mine. Let me know if you have questions about them. Alright, so now let's see if we can figure out end behavior. To figure out end behavior, I could take and multiply all of these together so that it's in standard form, and then I just look at the very first term. Anybody have an easier or better way to do that, Eugene?
Just look at the first parentheses and see if it's positive and then on the outside.
Okay. That would work unless one of these x's in here happened to be negative. Then that kind of throws a wrench in that. But because all of those x's are positive, and it's a positive out in front, I know it's going to be a positive leading coefficient. So I know that the right side is going to go up, but what about the left side? I mean, is this an even degree or an odd degree function? Okay, how do you know it's odd? There's 3 x's in it, so I know it's an x to the third. So it is odd, so that means the left and the right have to go opposite. Okay, so my end behavior was up, down. And now see if you can sketch in the middle of that graph.
Your indicator is backwards.
What's backwards? Oh, it is. That is not what came out of my mouth a minute ago, but that sure is what I wrote down. It is down, up. Alright. So while you're sketching it, I'm going to sketch it up here and then we can compare in a second. Alright, so if I were to ask you to do one of these on the test, everything I have in red should be exactly the same as what's on your paper. The part that's in yellow, it should all be going the same direction, but yours may not be as high as mine is here or as shallow as it is here. Okay, but it should be above here and beneath the x-axis here, and then we're all good. Okay, questions? Alright, so this morning I had somebody ask a question about, these I only had 3 solutions. They said, well, can you have more than 3 solutions? And I said, yeah. And they said, well, what about a multiplicity of 3? Will we ever have to graph one of those? Or will we have to graph a multiplicity of 2? And yeah, you might need to do those. I did not put those in the printed notes, so if you printed them, you're going to need to flip over on the back and add this. Okay, if you didn't print them, you're just going to keep going right along where you are. So if I gave you this equation, if I gave you that equation, could you solve it?
Yes.
Yeah. So let's go ahead and solve that one. I'm going to hit pause on my record while you guys work it, and I'm going to record it, and then we'll turn it back on. Alright, so take a look at what I've got. I had to set -1 equal to 0 because it's a factor, but does -1 ever equal 0? No, so I'm going to ignore it. The only reason I ever write that there is because sometimes you have an X out here and people forget about it. But even if it's out in front, it's technically equal to 0. And right here, I've got the same answer twice. So that is a multiplicity of 2. So that's going to do something a little bit different when we graph it. So I'm just going to sketch this one down here. Alright, so -2, 1, and 3 are my solutions. I got to do end behavior. We didn't do that yet. So what degree is this going to be? It's a 4th degree, and how do you know again?
How many x? 4?
I've got 4 x's, so I know this is an x to the 4th. All of these x's are positive, times a -1 makes it a negative x to the 4th. So I know they're going to go the same direction, but what direction do they both go? Down. So my end behavior is down, down. And now let's see if we can sketch in the middle of it. Okay, I have a multiplicity of 2 right here. So what happens to my graph? It doesn't pass through it. From here, if I start tracing it, it's going to hit right here, bounce off, and turn around. But after it does that, Then it's got to turn around somewhere so that I can go back through the 1. And then turn around again so I can go through the 3. Okay, and the height of the yellow parts, the highlight parts, yours may be different, but everything in red should be the same. It should bounce off here. Okay, those are the things I'll be looking for. Alright, and then one more. Alright, for this one, it is already in factored form. Set all of your factors equal to 0 and solve them. Now I've got x plus 4 3 times. Do we really have to write it down 3 times and solve it all 3? No. So that x equals -4, that is going to have a multiplicity of 3. Then when I solve this one over here, I've got to divide both sides by -1 so that I get x is 0. Alright, so I'm going to put my -4 and the 0. Now we've got to figure out end behavior. Okay, what degree is this going to be? 4, because I have 4 x's. Is it going to be positive or negative? Negative. So both ends are going to go the same direction. What direction will they both go? Down. And so now, I know that to get from here to this point, I've got to go above the x-axis. But because of this multiplicity of 3, when x is -4, when my graph goes through right there, it's got to do that little sideways wiggle and then go up and turn around. Okay? I don't know that I would make you graph one of those, but you should be able to recognize on a graph, if I ask you about multiplicities, you should be able to look at something like that and tell me that it's a multiplicity of 3. Or that this one up here is a multiplicity of 2. And the multiplicity of 2, I'll expect you to graph. Multiplicity of 3, maybe not. Alright, anybody still copying here? Oops.